Okay, so I'm going to walk you through the ocean current map and how your map should look to prepare for the quiz. I'm going to start off with the winds because I think that's easiest. So first thing you need to do is identify the equator. So the equator runs right through the center of Africa, and right there is Lake Victoria. So it runs right above Lake Victoria. So right there is my equator. And I apologize, it's going to be really messy because I'm trying to control this mouse here. So right there's the equator. So the wind belts go from 0 to 30 and 30 to 60 and 60 to 90. So what you want to do is make sure you know what each one of these latitude lines is worth. On this map, it's worth 15, and you can tell that because there's 6 lines, and we go from 0 to 90. So we have 1, 2, 3, 4, 5, and the top line is 90. So 90 divided by 6 is 15. So 0 to 30 is right here. And it's just kind of good to label it. 30 to 60 is right there. And then 60 to 90 is up here. Now, what we have with the winds, we have our trade winds coming in from the east. And they're basically going to blow towards the equator. So you want your trade winds coming down like this. And then in the south, 0 to 60. So there's right there coming towards the equator like this. Okay. And when we get there in this area in the middle, in this 0-degree latitude area, we get this area called the doldrums. And basically, we get a lot of heat, obviously, along the equator from the sun. And what that does is create a lot of moisture coming up out of the ocean, but it also creates some really sporadic weather. So sometimes the doldrums are associated with a lot of rain, and then kind of sporadic weather. Usually low winds is what we are talking about there in the doldrums. Now from there, we have the westerlies. Now, like the name sounds, going to come out of the west, whereas the trade winds come out of the east. And so our westerlies, and if you can think about this, the northern hemisphere, it's clockwise motion. So if this is our motion going this way, then our westerlies would move in this manner. Giving us a kind of clockwise motion there. And if you think about that, that makes sense with how our weather works. Our weather kind of usually pushes from west to the east across the United States. So if you think about these winds that control these currents, these surface currents that you drew up on your bigger map, and they control weather as well. The other westerlies in the southern hemisphere, we're going to make counterclockwise motion. So we got more of this type of motion here. From 30 to 60. And then we have the easterlies, polar easterlies from 60 to 90 coming out of the east and making a southwest motion in the Arctic, and then making a northwest motion in the Antarctic. Okay, so we got polar easterlies from 60 to 90. We have our trade winds. From 0 to 30. And then we have our westerlies I'm doing my best with my writing there. It's pretty bad. We have our westerlies there. Coming out of the west. And so again, the best way to remember that is make sure you break up your 0 to 30, your 30 to 60, your 60 to 90. And then if you can remember that there's clockwise motion in the north, counterclockwise motion in the south, that should help you with that. Okay, our next one I want to take a look at would be our surface currents. And I want to start with the cold currents here. And I just picked currents for this quiz where you're going to have to know these based off kind of which currents really affect our weather along the coast and in North America. So let's look down at the bottom there. You see surface currents of East Greenland, Labrador, Peru, Brazil, and the Gulf Stream. So we'll start with the cold currents. You have East Greenland, like it sounds. It's east of Greenland. So you got the East Greenland current coming down here. If you think about these currents are driven by the wind, so it's following kind of the pattern of the westerlies. And it's also bringing cold water from the poles. Okay. The Labrador current comes down west of Greenland and along our eastern seaboard. And then we have another cold current, the Peru current, which is again going to come from the poles and move north towards North America there. And then we have warm currents with Brazil and the Gulf Stream. And so the warm currents are going to come from the equator. So that's when you know which direction they're going to go. So it's going to come from the equator and move down along. And again, we're getting that motion of our global winds too. So you think about these winds kind of blowing this current towards the continent, and it's going to be deflected and moving south along the coast there. And then the Gulf Stream current, again, coming from the equator and moving up along out of the Gulf up along the eastern seaboard. And so those are our surface currents you're going to need to know. You're also going to need to know the North Pacific gyre. That's going to be in the North Pacific as it sounds. It's off the west coast there. You don't necessarily need to know that it is a cold current, but it is a cold current coming down the coast there of California. And then we get a gyre is a circular motion current here. So we basically get this big recycling event in the North Pacific. And that's where a lot of our garbage gets caught up. That's the Great Pacific Garbage Patch. Okay. And real quick there, looking at some of these other ones down in the box you'll need to know. The Great Barrier Reef. That's a large coral reef off the east coast of Australia there. I'm going to highlight that right there. And then let's take a look at the thermal haline or deep ocean currents. Now this one, I want you to do your best on the quiz. It's going to be kind of difficult to remember, but I'll give you some tips here. Okay, so first of all, we get motion kind of coming down through here, right through the Atlantic, and then working its way back up along right through kind of Australia, up near China, and then we get a little bit kind of circling up here also in India as well. And again, these kind of follow the equatorial patterns of our heat, but these are driven by density and salinity. Okay, so it's not necessarily winds that are going to have a big factor. Ocean temperature does affect these, and these are driven by temperature, but it's more about the density and how the temperature has affected the density, which is causing this motion, this movement. Okay, so I want to take a look at the global conveyor belt, or that thermal haline that moves through the Atlantic and Pacific. We get motion coming down out of the poles here, moving along. down through south of Australia. Up. Get a little division through here. Change that to red. Get that motion coming down. Like a loop here, okay? Again, thermal haline is driven by temperature, density, salinity. Deep ocean currents are not affected by wind. They're not really all that affected by the sun, but it's more about the overall temperature of the ocean. These currents take thousands of years to circulate. They're not controlled by the surface winds. Our surface currents can travel all the way down like about 400 meters. So these are deep, multiple kilometers deep in the ocean, on the ocean floor. So some of these 5-6 kilometers deep as they move through the ocean. But this is going to regulate the Earth's temperature and the ocean's temperature in general. Very important phenomena in our oceans. So this is what your quiz will look like. I'm not going to go through your continents and oceans. You should know those at this point in your life. But let's talk real quick about Tropic of Cancer, Tropic of Capricorn. Those are at 23.5. I know we don't really talk about those a lot. Cancer is in the north. And so again, you want to make sure on this quiz that you're looking at your lines properly. So that's 15, that's 30. So 23.5 is going to be right about in that region. That's going to be your Tropic of Cancer. And then here's our 0, 15, 30. So our Capricorn is going to be about right here. Your Arctic Circle and Antarctic circles are going to be at 66.5. So right there, that is 65. So that's actually 75. So it's going to be right about in this region. Okay, and that's Arctic. And in this region, 90, 75, 60, so right about here, that'd be Antarctic. And again, I apologize for this, it's really crazy. Okay, so I hope that helps, and go ahead and copy that in, all right?